Low Country was spared from many of the impacts from Isaias. Today, I talk with forecaster Jared Smith of Charleston Weather for this edition of Quintin's Close-Ups. And if you haven't already, subscribe to my YouTube channel and like Quintin's Close-Ups on Facebook. Jared Smith, welcome back to Quintin's Close-Ups.
Hey, Quintin, good to see you.
Yes, sir, absolutely. Obviously, you are a forecaster for at Charleston WX, Charleston Weather. And I want to talk to you, obviously, about Hurricane Isaias. And from, let's say, from 10 a.m. yesterday morning to right now, what is the biggest difference about this storm in your mind?
Well, 10 a.m. yesterday, we were still thinking that we would have at least, we went into the morning thinking that there was the potential for a really nasty combination of the peak storm surge, high tide with a king tide, no less, and a band of heavy rainfall setting up over downtown. As we got into about 10:30 or so, we started to realize, okay, the storm is moving a little bit faster, and the good news is that we weren't going to have that peak storm surge around that high tide, which is good, but still, when you get the kind of rainfall that a tropical system was, that the tropical system was forecast to do, you certainly continue just to remain concerned about the flooding impacts and those issues. And then something, darn near miraculous happened in that the heaviest band of rain, it was wrapping around the center. That center was pulling a little bit west, pulling a little bit east. Those little wobbles. It's tough to pin down. And what happened was fascinating. And it reminded me a bit of what happened in Irene. Right. We had a very similar setup in Irene where that band of rain got so close. And it didn't, and it just and the position of the center was just east enough to keep it out of downtown, and so I go downtown last night and I drive around and the only road I see underwater is Cherry Street, and I know if I spill a bottle of water or something like that, Cherry Street's underwater for days, and so. And I'm just astonished. It's just fascinating. The flood reports are very few flood reports yesterday. We had a couple closures, but that really is the thing that was honestly most relieving, if nothing else. It was just man, I'll tell you, I was pretty surprised and pleased, especially we got that center through there, and then it came, and I got to tell you, it came just within maybe 5-10 miles. And that was a big difference because I had people picking up an inch an hour over in Isle of Palms, fortunately moved out very quickly. And if you look at the observations this morning, station in McClellanville had 4.5 inches of rain, whereas I didn't even record an additional inch of rain yesterday here in West Ashley.
Wow. You talked earlier about, obviously, the center of that storm when Irene came. Where was it for, obviously, Isaias?
Mm-hmm. Yeah, so the center of the storm in Isaias, it was, it paralleled the coast maybe 50, 60 miles offshore. So it came very close, and it was reorganizing at that time. And it was, as we know from later that night, it reorganized back into a hurricane, and what ended up being a pretty formidable hit. It might have been just a Category 1, but don't tell that to the people in Oak Island this morning, Oak Island, North Carolina this morning. Right. Don't tell that to the people in Conway and Myrtle Beach. Spring May Pier saw its third highest tide on record, behind only Hugo and Matthew. So I don't think I can underestimate and understate just how lucky we were, because 50 miles. All right, okay, that's pretty good. You wobble that 10 miles in, and you're in that band of rain downtown, and we're talking about a much different outcome this morning than we are now.
And what exactly were you watching from the satellite during those particular hours?
Mm-hmm. So looking at the satellite, the things that we were looking at, a couple things. There was one, we were constantly monitoring to see where the thunderstorms were bubbling up, and I mentioned this a couple times, during our Carolina Weather Group broadcast last night, and throughout this event, Isaias has not been the most photogenic storm on satellite. The Hurricane Center is not putting this on their business cards, but because it was undergoing lots of wind shear, a lot of land interaction. But as it made that turn to the north, we started to see get better organized on the radar. But if you looked at it on a satellite, it looked like it looked like nothing. It looked like a complete joke.
Yeah.
But it was no joke. It was a pretty powerful storm. Part of that was because if you begin to look at the satellite as it moves, as it starts to move up the coast, and you can see it very well today, the trough of low pressure that was digging in to help steer it north was helping to ventilate the storm on the west side, and it produced almost like something we typically see in winter called a baroclinic leaf, and it basically is like the visual representation of the divergence evacuating air out of the storm. And it's interesting because normally hurricanes don't intensify like this. There's going to be a lot of research done on Isaias because this was a weird one. But this was the reason why all of the rain eventually displaced to the west side of the storm. In Florida, when it was by Florida, it didn't have that upper forcing to work with, and the east side of the storm, Bahamas, were getting nailed for a couple days. Whereas Florida, they were just seeing some showers and some gusty winds, but it looked like very, very close to nothing on satellite, on radar in Florida at the time. So again, once we got that little bit of forcing in there, helping to ventilate the storm and helping to make those rainfall more efficient, that is when we started seeing that the effects of that help spin up the center of circulation on Isaias.
And let me ask you this, Jared: was a sting jet obviously had any impact on this particular storm by chance?
Well, it was the upper trough. It was that that upper level divergence. It was that digging in quite a bit for August, by the way. And if you looked at it, it's like this is August. It looks like September, so you get those short waves that dig in, and it helped dig in the trough, and again, with that good positioning of the center of the storm to the east of the trough, helped it to ventilate, helped it to and then the thunderstorms could blossom up, and the storm still being over warm water, 85 degrees over the Gulf Stream, with plenty of with depth to that water, so it wasn't upwelling or anything like that, weakening itself. You get all those little atmospheric pieces in place, as well as the water temperatures and the SSTs and the ocean heat content, and it just all those things working together to help strengthen the storm. Unfortunately for the people in North Carolina.
Yeah, and where exactly did the storm have any impact with land?
Yep. So it interacted with land, throughout much of its journey. As you recall, it had interactions with Hispaniola. Puerto Rico got a lot of rain. They had some significant flooding there, all the way up through the Dominican Republic and Haiti. Around the Dominican Republic was one of the touch points where we thought, okay, maybe, let's see what this does, because, Hispaniola is known as a cyclone killer because it's very mountainous. Right. And that tropical cyclones are they're very delicate heat engines. And if you throw them off of balance or anything like that, they want to be vertically stacked and left alone to properly ventilate and take in, new warm, moist air to help just keep the cycle going. And when you disrupt a tropical cyclone, either through wind shear, tilting the storm, or through mountainous terrain, disrupting the inflow to the storm, then you're going to typically see weakening. What happened with Isaias is that actually the orography may have helped to regenerate the center further north. And so we had several blowups of thunderstorms, and the original center dissipated over Hispaniola, and a new center came together to the north from the mid-level center, and was able to then resumed its journey to the Bahamas, encountered Andros Island. And then at that point, we saw a stunning collapse of the convection on the northeast side of the storm. Watching the satellite, the cloud tops just completely warmed up. You could see the little naked swirl of Isaias, which actually was the best it looked on satellite, as it got over water. And it's like, okay, let's wait and see. Because there was a possibility that this could have even just drifted into Florida. The European model that morning actually had a solution. The operational model had a solution in which a very weak Isaias center went into Florida, and that was it. But that didn't come to pass. There was a large blossom of thunderstorms on the north side of the center, and that kept it going. and that strengthening made the storm a little bit deeper, more susceptible to the turn to the north, to the northwest, to the north, and then rounding around high pressure to the east. The trough, the aforementioned trough to the west, pulls it into South Carolina, and then it scrapes the Florida coast, and then last night, around about 11:10 last night, it makes landfall somewhere near. Oh goodness, I should have this off the top of my head.
No worries.
But yeah, it made landfall. God, what was the name of that place? It was late. Yeah, but let me get that for you real quick. But it makes landfall, on the southeast coast of North Carolina, 40 miles south of Wilmington.
Right.
And you're looking at weather stations on Oak Island, Bald Head Island, and we saw, consistent gusts. We saw Bald Head Island gusts to 99 with a sustained wind of 75 to 80. So, so it was that was a really tough storm. We actually talked to a guy last night on the Carolina Weather Group, Ethan Clark. He's an intern at WRAL, a sharp dude, meteorology student, and he was in the eye. He was in the eye. He measured a pressure of 987 millibars with his handheld handheld weather station. He was in the eye, and he was witness to several large fires actually that came up due to storm damage and maybe electrical lines shorting out. Saw a lot of power flashes, but he was in the calm of the eye. He actually called in from the calm of the eye. It was weird, man. It was crazy. So I got to tell you, it was, and now it's just plowing up. It's just plowing up the East Coast. The center of the storm is continuing to spawn tornadoes. There's a potential tornado outbreak in progress now, going up towards Virginia, Maryland, into New England. So certainly, certainly, it's going to be a storm that's going to affect a lot of people beyond, even just its tropical life.
And let me ask you this: how many total thunderstorms were there in this particular storm?
It's hard to say just how many specific updrafts there were. I mean, again, with these storms, you get these, you get the feeder banding features, and the way the hurricanes, sustain themselves is that the thunderstorms on the outer bands will, release latent heat that feeds the machine, so to speak, and that all gets, and then that's how all of that, that vortex sustains itself. Rising air at the center, sinking air for the eye, blowing out on the central dense overcast. At least that's the idea. But for here, we didn't, thunder-wise, we did have a few thunderstorms ahead of it, but it was mostly just rain squalls. When it got into North Carolina, we started having problems with tornadoes. Several tornadoes that touched down, and a couple did some pretty substantial damage. Damage surveys will be ongoing this morning in those areas. But we were working several tornado warnings last night, up in the New Bern area as well as towards Elizabeth City. And a lot of stuff spinning up, spinning down very fast. And those Weather Service warning operators, I'll tell you what, they have to be on their game. That is not, it's not easy on a good day. In a tropical system, it's an absolute nightmare to warn on those things. So, we cannot appreciate them enough.
And back here in the Low Country, obviously the rain, from what I understand, from 12 until 6 o'clock. What exactly were those rain totals?
So looking at some of the cooperative stations, rain totals ended up being about an inch and a half across much of the Tri-County. What we found is that there was a pretty substantial rainfall gradient. St. George, a station up there, only got 0.55 inches of rain, and that some of that might have come from actually remnants of another blow up from a stationary front to the west that made its way towards the coast on the backside of Isaias. And so it might not have even been the tropical storm contributing to some of those rainfall totals up there. But as you get closer to, downtown, the airport, I think, had 1.1, 1.2 inches of rain. And then as you get further east, you start getting to the 1.75s, the 2-inch totals, getting close to North Mount Pleasant, you start having those eastern Berkeley County. And then there was a station in McClellanville that was about 4.5 inches, like I mentioned earlier. And so Very sharp rainfall gradient, very hard thing to forecast for again. And once again, the tightrope that we walk in communicating these things is that, one, we want to say that don't focus on the center position, because the center position is not necessarily important because the impact spread for miles. This is true. But what is also true is that the center position can make a world of difference in these kinds of scenarios where you have dry air eroding the western side of the storm. If that center moves 20 miles is the difference between us talking about a long-duration flooding event in downtown Charleston and marveling at sunsets.
And how much dry air was it when it finally arrived at Charleston?
So, the moisture content was pretty substantial. A measurement of moisture that we like to use in the weather world is called precipitable water, and it basically is you take a whole column of air from the atmosphere and you wring it out like a towel, and the resulting amount is the precipitable water. Typical August day, precipitable water values are usually 1.9 to 2.2 inches. That's pretty standard around here. This is a subtropical climate, especially during the summer.
Sure.
And it's hot and humid, right? I mean, that's what we do. That's Charleston. With Isaias, precipitable water values were approaching 3 inches. That is pretty extreme. I mean, that's something that we only see with hurricanes. And so you had that big plume of moisture that Isaias was within. And keep in mind too that we also had that, again, that upper trough that helped to focus the pipeline of that moisture north. But also around that upper trough, you had drier air eking its way in, eroding the west side of the storm. And that's why we had that sharp rainfall gradient. So, there was a fair bit, but again, we were within that moisture plume as it was moving north. And so that's how we were able to wring out a fair bit of rain. But again, the best forcing from that, from the center and some of the rain bands actually didn't come into focus until much later.
And what was that sharp rainfall gradient?
Yeah, so basically, again, this goes back to that, the erosion on the west side, and if you look at I'll go back and look at some of the radar images from yesterday, you'll see that you'll see Somerville was in basically a light rain all day. I mean, West Ashley over here, I had 0.72 inches overnight from some of the initial rain bands, and then 0.97, 0.98 from the rest of it. Right. And it's like from what the main event was, so to speak. And so again, in West Ashley, we were kind of on the edge of that, where we were in the rain shield. But if I went 40 miles west, it was dry. It was dry as a bone. There was a station in Walterboro that I think got 1/4 of an inch only because of the storms that had rotated through after Isaias. So that's that rainfall gradient. Again, you get to a very sharp cutoff. And I remember, last night when the center moved out, when it finally moved out, the rain just stopped. You could see the clearing breaking in the distance, and it just stopped. And as I say, yeah, it's like here 1 minute, gone the next.
On the next. And how many storms rotated down there in Walterboro in your mind?
Well, Walterboro, again, that was a decaying line of thunderstorms that had developed in Georgia and was moving eastward with the upper level system and the stationary front. And so you had those advancing thunderstorms that were decaying. It was running into an atmosphere that had obviously been pretty worked over by a hurricane and or tropical cyclone. At the time, it was not a hurricane. It was a hurricane later, but semantics aside, just a few showers and thunderstorms, had worked their way in, and, they eventually dried out. But we saw some of that activity wrap back into
Oh, I lost you.
Chester County as well. And that's why I think that, are you good?
Oh, yeah, I can hear you
now. Okay,
yes,
good. Yeah. So we had, the wraparound in Dorchester County as well, which is why I think some of those rain totals were also inflated.
Inflated. Is that usually the case with, obviously, those totals being inflated?
Well, I guess inflated might have been the wrong word, truth be told, but you're fine. That's my bad. But why some of those totals were maybe even a little bit higher than they would have been if it was just Isaias. Again, you're not used to seeing a lot of not used to having a cold front that close, especially this time of year. Bringing in thunderstorms on the back end of it. but it was wild watching the satellite because, I mean, that was a very conceivable scenario because, you know, where we were in thick overcast almost all day in Charleston, if you went to Walterboro, you would have seen partly cloudy skies all day. And so, you know, and the temperature difference was substantial too. I mean, we got to about 80, 82 in Charleston just in the morning, and then it was in the 70s for much of the day. You go over to Barnwell, it was 90.
Right.
I mean, so again, the where you had the Isaias and where you didn't was a major temperature change, and as a result, sometimes you can get those, you know, you get a little forcing mechanism, which we had at the surface and aloft, and you got that line of thunderstorms that came out of Georgia. You're not used to seeing follow-up thunderstorms after a tropical cyclone, but this is 2020. Anything is possible.
Anything's possible. And is there any history of follow-up thunderstorms in this area after a storm?
I will admittedly say that that's probably not something that we track very much. I just know that felt unique to this story. That felt unique to this. It's I'm used to, you know, tropical systems kind of clearing the area, and then typically what happens on the outer edges of a tropical system is that part of that heat engine, you have the updraft here. It kind of ventilates out from the top, and then you have sinking air on the edges, and that sinking air is what causes the calm before the storm. That, you know, that's not just an expression. It's rooted in some scientific truth, and so you get that sinking air that, you know, tends to prevent showers and thunderstorms from firing up around it. You can often have cloudless skies around a strong tropical cyclone, but in this case, the cyclone, you know, was one fairly disorganized. Only got its act together, you know, within 6 hours of landfall. And two, again, as we talked about before, the kind of the unconventional forcing mechanism that helped ventilate the storm from the west as it was moving up to the north and northeast, that upper trough helping to, you know, ventilate that. That was a little more of a conventional style, some conventional style synoptic meteorology as opposed to purely tropical meteorology.
And let me ask you this too, without really a high tide, and some people are thinking not enough strong winds last night, did we ever receive a storm surge?
It does appear that we had 2 feet of storm surge, but it was all below flood levels. I mean, so we had about 2 foot departures roughly around 2 or 3 o'clock. So that's when it peaked. Because again, you know, you got to have, you know, you need pretty much southeast winds. You need to, you know, with the way our coast is aligned, you need basically that straight, that straight wind into the harbor to help push that water in. But once you start getting the wind directions around to the northeast and the north, then that water is not going to pile up as efficiently. And so that's why, you know, so our surge peaked around, you know, 1, 2 o'clock or so. I'll have to go back and look at the exacts, but we didn't notice because it was, you know, we were kind of we were in low tide and made all the difference in the world. Had the center been on the Hurricane Center forecast position from the day before, we would have been in a much different situation because we would have been peaking that storm surge around 6 or 7 o'clock because before the 8 o'clock position, the 8 p.m. position was going to be southeast of Charleston. So you can imagine, you know, on the north, you know, on the north side of that circulation, we still have some pretty decent onshore flow there in that scenario. But fortunately, the storm did speed up.
And what was that wind direction between 2 and 3 o'clock?
So between 2 and 3 o'clock, we were looking at it. It was starting to come more out of the direct east and eventually started swinging around east northeast a little bit. And, you know, and as the storm moved up, as it got parallel to us, those winds swung around more sharply to the northeast and then to the north. And then at that point, they, you know, coming around the backside of the circulation, they go northwest, and that starts to blow the water out. In fact, it was interesting last night. High tide was technically at 8:59 p.m., but it peaked about 30 minutes prior because, you know, I mean, the wind had started turning offshore. Sometimes we see this very starkly, like in Matthew, for example. I'll never forget this. In Matthew, as it moved very quickly up the coast. We had pretty significant surge in Matthew. We had an 8+ foot tide in Matthew Mark Sudduth from HurricaneTrack.com, he installed a camera down at White Point Gardens, and you could see the White Point Gardens completely underwater, joining, basically joining, joining the harbor at that point.
Right.
And then when that center came around, the winds behind it were so strong that you could see the white caps of the water being pushed out, and you could see it draining naturally, just by virtue of the water being pushed out. And if you look at the tide gauge, you'll see it usually the tide gauge is a nice little sine wave, but in this case it did like this, and it actually went below predictions for a while. So we didn't quite get that with this one. We again, the wind fields were very asymmetrical with Isaias, but which again is kind of typical of these kinds of events where you have a strong where it's a little less than tropical, but not quite not tropical, if that makes sense.
Sure.
To our viewers at home. But yeah, it was fascinating, to say the least, to see that in Matthew. And it was more subtle this time, but it was there. And again, the tide only topped out about 7.33 feet last night. And while that does cause some flooding in parts of downtown, especially towards the Riverdog Stadium and Haygood and Fishburne, that area there, towards the Citadel.
Right.
Incredibly, nothing was closed. That shocked me.
Yeah, I saw. Yeah, the Charleston Police Department said there are no road closures tonight, so everyone was relieved.
I was stunned. I was absolutely stunned. But again, that goes to that's not just that's not just dumb luck either. That's that is work that we've put in. 7.2, 7.3 feet. You remember East Bay Street used to be just reclaimed by the East Bay, right? Reclaimed by the Bay. And since the check valves and everything were installed, a year or two ago, we don't have those kinds of problems there anymore unless the tide is super high. So, so some of the resilience work that we have done has been very helpful in this regard. And that has been good. That has been, quite helpful, and it helps us stand up to this, because this is, because as this problem is not going away. We are Charleston, being a coastal town with sea level rise and other factors, and potentially a higher frequency of storms. I mean, this is a problem that is not going away. We're going to have to learn to live with it. So we are starting to learn to live with it.
And I know you talked about it just a tad bit earlier in the interview, but let me ask you this bluntly. Why weren't there any hurricane warnings or tornado warnings here versus hurricane warning on the Grand Strand?
Mm-hmm. That was an excellent warning decision by the Hurricane Center and the local National Weather Service offices. I want to start there. No hurricane warning here because hurricane force winds just were not likely. Where we were in relation to the center of the storm, the hurricane force winds were going to be decidedly lopsided to the east of the center, where there's less friction. And generally that part of the circulation is going to be a little bit stronger, better wind shear in that part of the circulation helps spin up tornadoes. The way we were oriented, with the storm did not lead itself well to tornadic activity. Typically you need to be in that northeast quadrant, not always, but in that northeast quadrant, and the north side of the storm is where you have the best low-level wind shear to cause tornadic activity. So a couple things happened with tornadoes. One, we got cloudy and rainy very quickly. We had very little atmospheric instability at that point. And two, Isaias just was not as strong. The storm just was not as strong at that point when we were on the north side of the circulation. So we weren't seeing that parade of rotation that we typically are used to seeing. Like with Irma, for example, we were for hours we were looking at landfalling circulations of potential water spouts that did turn into tornadoes during Irma. That didn't happen here. We were just too stable. Now, if we had some peaks of sun, if it was a typical hurricane rain band scenario where we had peaks of sun between bands, that could have allowed the instability to build a little bit, and then we might have had some additional issues with tornadoes. But that didn't happen. But as the storm got better organized, got stronger, we started to see that. we started to see those issues begin to move into southeast North Carolina, and they're particularly susceptible because of the way they stick out.
Yeah.
They're going to be, with the the geography, just with the way that works. Southeast North Carolina is particularly susceptible to tropical tornadoes. Last night was no exception. As far as a lack of a hurricane warning, again, when the forecasts were issued, it was very unlikely that it was going to be a hurricane. As we got through the day, late Sunday into Monday, we started, the Hurricane Center, began to look at this as like, hey, yeah, this could be a thing. The wind shear was going to relax a little bit, and it was going over Bathwater. It was going over the Gulf Stream. And it was certainly possible that it could, with the assistance of, some, additional upper level features, that it could re-intensify into a hurricane. And that did come to pass. But again, no hurricane warning here because, that center of circulation was going to be to our east. Tropical storm warnings, they were in effect, as you know, more than covered it. That worked out well. Storm surge warning, again, that was a little scary for some people, but storm surge warning, very useful tool, very good, very good to warn people of the impending dangers of storm surge. Fortunately, it wasn't that bad this time, but it could have been. And again, just with our geography does a lot to keep us safe, as far as the way that, that we're kind of like, the way our coastline is set up, it saves us time and time again, I feel like, especially from these coastal runners.
Yes, indeed. Well, Jared Smith, thank you so much for your time. And again, welcome back to Quintin's Close-Ups.
Thank you, Quintin. Good to talk to you as always. Hopefully under happier circumstances next time.
Oh, yes, sir. We'll believe in God for that.
Mm-hmm.